systems of equations. A linear system of equations is represented by two straight lines or equations. The point of intersection, which we shorten down to POI, of the two lines is the solution of a linear system. And we often call that a linear system of equations. So the POI coordinates will make the equation true when x and y, so whatever the numbers happen to be for that point of intersection, are substituted into each equation. And we can check to see if the solution is correct by substituting the solution back into the equations to see if the left side of the equation equals the right side. So those are those left side, right side checks that we did when we looked at solving equations. So there are three different ways that we can find the solution to a linear system of equations. The first is by graphing. The second is by substitution. And the third method is elimination. We're going to start with graphing because sometimes it's easier for us to identify the point of intersection, and it's also easier to see the applications or how to interpret those system of equations in terms of applications or real-world situations. So let's start by solving linear systems of equations graphically. So some problems are solved by graphing the linear equations on the Cartesian plane and finding where they cross. So that's finding the point of intersection, so the coordinates that make that true. So the point of intersection is called the solution of a linear system of equations. So we're going to find the solution or the point of intersection for each of these three graphs. If I take a look at this first graph, these two lines intersect at this point right there, which is the coordinate +2 and +2. So remember, we always identify the coordinate that goes left and right first, and then the coordinate that goes up and down, or the x and then the y. For the second set of linear equations, we take a look at where they intersect, and they intersect right down here, and that's the point 5 and -4. So we always go across first to the number and then down or up. And then last one intersects right up here, and this is the point of -3, +5. So that's the simplest thing that you can do. So if the graph's already given to you, you can identify where they intersect from that graph or from that picture. So now we're going to take a look at how we do it when we have to solve or we have to make our own graphs and then find that point of intersection. So we'll start with the first example. So when we're graphing an equation of a straight line, sometimes it's easier to put it in the form y = mx + b. And remember that the m stands for the slope, so that's the steepness of the line, and the b stands for the y-intercept, so where it crosses that y-axis. And those are the two pieces of information we need in order to graph an equation of a straight line. We could also graph it using the x-intercept and the y-intercept if it's given to us in standard form. Sometimes, though, they don't work out to be nice whole numbers. So by converting it into slope-intercept form, we can easily identify our slope and y-intercept to make it graphing. So it doesn't matter which way we do it. So I'll do, for this first example, I'll do the first equation finding the x and y-intercept and plotting those, and then I'll do this second one by converting it into slope-intercept form. So you have an idea of how to do it for both ways. So if I was to find the x-intercept first, I need to substitute y equals 0 into my equation. So I have x plus 0 equals 6, or x is equal to 6. So that means I have a point, or the crosses the x-axis at 6. So right here. If I was looking for the y-intercept, I need to substitute x equals 0 into my equation. So I have 0 plus y equals 6. So y is equal to 6. So then it crosses the y-axis at 6, so right here. So then what I could do is I could connect these two using a straight line. So that's equation 1. So I'm going to call this A, and I'll label it A right here. So then I'm going to do the second one, but instead of finding the x and y intercept, I'm going to rearrange this into slope-intercept form. So the easiest way to do that is to move the y over so that it becomes a positive value. And to do that, I need to add y to both sides. So I have 2x, negative y plus y is 0, so that disappears, and 0 plus y is y. From here, I can identify that the slope is 2, or 2 over 1. So that means I go up 2 units and across 1 unit. And my y-intercept is 0 because there is no constant value being added or subtracted to my x. So I'm going to start by plotting my y-intercept at 0. And then from here, I'm going to go up 2 and over to the right 1. Up 2, over to the right 1. Up 2, over to the right 1. And from here, I'm going to connect these again using a straight line. And I'm going to call this line B. And from here, I identify where they intersect, and it looks like our point of intersection is at the point 2, 4. And I can check this work by doing the left side, right side check for both of my equations. So we'll start with equation A, and I'm going to create my t-chart, left side, right side. The left side of my equation is x plus y. The right side is 6. I'm going to substitute the values in from my point of intersection into my equation. So x is 2 and y is 4, and 2 plus 4 equals 6. So far, so good, right? So my left side equals my right side. I'm going to do the same thing with my equation 2. So the left side and the right side. The left side of my equation is 2x minus y, and the right side is 0. Again, I'm going to substitute in the values for x and y. So 2 times 2 minus y, which is 4. So 2 times 2 is 4, and 4 take away 4 is 0. So again, the left side equals the right side. So my concluding statement would be that the left sides equal the right side. Therefore, the point of intersection is the coordinate 2, 4. Let's do another example. For example number 2, my first equation is already rearranged into slope-intercept form. So I can quickly identify, I'm going to first say that this is equation A, and my slope is 1. So remember, if there is no number in front of your x, that's an imaginary 1. I can also turn this into a fraction by putting it over 1. So this means that I go up and then over to the right, and my y-intercept is 3. So here I'm going to go ahead and plot my y-intercept at 3, and I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. Okay, so that is my equation of the line or my line on my Cartesian plane. I might want to also see what happens on the left side of my y-axis. Instead of going up though, I'm going to go down and I'm going to go to the left one. Because sometimes they won't always intersect on the right side of the graph, so you might have to extend those lines so that you can find that point of intersection on the left-hand side. So once I've plotted every single point that I can, I'm going to go ahead and connect these using a straight edge. And this is graph A. So for example 2, my second equation, I'm going to go ahead and solve for or rearrange this equation so that it's in slope-intercept form. So I'm going to start by subtracting 3x from both sides. So 3x take away 3x is 0, so I'm left with y plus 1 on the left-hand side, and 0 take away 3x is negative 3x. From here, in order to isolate for y even further, I'm going to subtract 1 from both sides. So plus 1 take away 1 is 0, so I'm left with y is equal to negative 3x take away 1. So my slope is negative 3. I can turn this into a fraction by putting it over 1. So this means that I go down and then to the right. And then my y-intercept is at negative 1. So I'm going to plot my y-intercept at negative 1. I'm going to go down 3 over 1. And I can't go down any further. And we'll notice that I don't know where that point of intersection is yet. So I'm going to go and look what happens on the left-hand side of my y-axis. So instead of going down, I'm going to go up 3 and to the left 1. And there's my point of intersection. So I'm going to connect these points using a straight edge. And I'm going to label this line B. So it looks like from my graph that I have a point of intersection at the coordinate negative 1, 2. And I can verify this by doing a left side, right side check for both equation A and equation B. So for equation A, my left side of my equation is y, the right side is x plus 3. I'm going to substitute in the values for x and y from my point of intersection. So my left side is 2. My right side is negative 1 plus 3. So my right side, if I simplify this, negative 1 plus 3 is 2, so my left side equals my right side. I'm going to do the same thing with equation B. So the left side is 3x plus 1, or plus y plus 1, and the right side equals 0. I'm substituting in the values of my x, which is negative 1, remembering to multiply those two together, plus my value for y, which is 2, plus 1. 3 times negative 1 is negative 3, 2 plus 1 is positive 3, and negative 3 plus 3 is 0. So again, my left side equals the right side, so I can write my concluding statement. The left side equals the right side, therefore the point of intersection is negative 1, 2. From here, I'm going to go to my third example. And again, it's just practice converting or rearranging these into slope-intercept form. So I'm going to start with equation 1. And I'm going to rearrange this so I isolate for y. I'm going to start by doing that by adding 3x to both sides. So I have 2y, negative 3x plus 3x is 0. And then I have my 3x on the left-hand side now, plus my 12. From here, I'm going to divide by 2 to isolate for y even further. So 2 divided by 2 is 1, so I'm left with 1y, or just y. 3 divided by 2x plus 12 divided by 2. And I can go ahead and simplify my y-intercept portion. So 12 divided by 2 is positive 6. So I know that my slope is 3 over 2, and I know that my y-intercept is 6. So I'm going to start by plotting my y-intercept at 6. And from here, I normally would go up 3, but I'm going to run out of my grid. So I'm going to go down 3 instead, and then over to the left 2. Down 3 to the left 2. Down 3 to the left 2. And I'm going to connect those points using a straight line. And I'm going to label this A. So I'm going to go ahead and look at my second equation, which I'm going to label B. Again, I'm going to isolate for y. I'm going to put this into slope-intercept form. I'm going to do that first by adding x to both sides. Negative x plus x is 0, so I'm left with 4y is equal to positive x, or just x, plus 4. And then from here, I'm going to divide both sides by 4. 4 divided by 4 is 1, so I'm left with 1y, or just y. Remember, there's an imaginary 1 in front of this x, so it's 1 divided by 4, x, and then plus 4 divided by 4. Again, I'm going to go ahead and simplify where I can. 4 divided by 4 is 1. So my slope is 1 over 4, and my y-intercept is 1. So here's my point, my y-intercept at 1. I'm going to go up 1 and over 4. Now I can't go any further, and I don't have a point of intersection yet, so I'm going to go down 1 this time and over to the left 4, and there's my point of intersection. So now I can connect my points using a straight line. Your line will be much straighter than mine. And I'm going to identify my point of intersection, which is at the coordinate -4, 0. And I can verify that by doing my left side, right side check. So for equation A, the left side of my equation is 2y minus 3x, and the right side of my equation is 12. I'm going to substitute the values in for x and y from my equation. So 2 times 0 minus 3 times -4. 2 times 0 is 0. -3 times -4 is positive 12. And 0 plus 12 is 12. So the left side equals the right side for that equation. Now I need to do the same thing for my second equation. The left side of my equation is -x plus 4y. And the right side of my equation is 4. Again, I'm substituting in the values for x and y from my point of intersection. So I have -x, which is -4, plus 4 times 0. Negative times -4 is positive 4. 4 times 0 is 0, and 4 plus 0 is 4. So again, that left side equals the right side, so I can say with certainty my concluding statement is the left side equals the right side. Therefore, the point of intersection is the coordinate -4, 0. We'll do one more simple or straightforward example, and then we'll look at an application question. So example number 4, again, I'm going to identify which one is equation A. So my first one will be equation A. And I'm going to put this into slope-intercept form. I'm going to do that by adding 4x to both sides. So -4x plus 4x is 0. So I'm left with y is equal to 4x plus 6. From here, I can say that my slope is 4, or 4 over 1, and my y-intercept is 6. Again, I'm going to plot that y-intercept at 6 here. Normally, I would go up 4 and to the left or to the right 1, but I can't. I'm going to run out of my grid, so I'm going to go down 4 and over to the left 1, down 4, over to the left 1, down 4, and over to the left 1. And I'm going to connect those using a straight line. And I'm going to label this at line A. On that same Cartesian plane, I'm going to label line B. Again, I'm going to isolate for y. I can do this a few different ways. I can either move my y over first, or I can move my number over first. Doesn't matter. I'm going to go ahead and move my y over. So I'm going to add 3y to both sides. So I have x is equal to 15 plus 3y. So I've eliminated that 3y from the left-hand side because negative 3y plus 3y is 0. From here, I'm going to get rid of the constant that's on the same side as my y. So I'm going to subtract 15 from both sides. So I have x minus 15 is equal to 15, take away 15 is 0, so just 3y. And lastly, I need to get rid of the coefficient in front of my y. So I'm going to divide every term by 3. Remember that imaginary number in front of your x is 1. So I have 1 divided by 3x minus 15 divided by 3. 3 divided by 3 is 1, so I'm just left with 1y, or just y. Let's go ahead and simplify that second term on the left-hand side. So I have 1 over 3x. Negative 15 divided by 3 is negative 5, and that's equal to y. So my slope is 1 over 3, and my y-intercept is negative 5. So I'm going to start by plotting my y-intercept at negative 5. From here, I go up 1 and to the right 3. Up 1 to the right 3. But I don't have a point of intersection yet, so I'm going to go backwards. I'm going to go down 1 and to the left 3, and there's my point of intersection. So I'm going to connect those points using a straight line. I'm going to label this one B, identify my point of intersection from my graph, which is right here. So my point of intersection has the coordinate of negative 3, negative 6. And I'm going to confirm that by doing my left side, right side check for both equations. So I'm going to start with my first equation. The left side is negative 4x plus y. My right side is positive 6. I'm going to substitute in the x and y for my point of intersection. Negative 4 times negative 3 plus negative 6. Negative 4 times negative 3 is positive 12. Minus 6 is 6. So that works for that one. Let's confirm it for the second equation too. The left side of this equation is x minus 3y, and the right side of the equation is positive 15. Again, I substitute in the values from my point of intersection. So negative 3, take away 3 times negative 6. I have to follow order of operations, so I must do my multiplication first. Negative 3 times negative 6 is positive 18. Negative 3 plus 18 is 15, and again, that left side equals the right side. So I can say with certainty that the left sides equal the right sides. So therefore, the point of intersection is negative 3, negative 6. And one more example, sort of an application question. So both the Girl Guides and the Boy Scouts are hiking through Algonquin Park. The Girl Guides are traveling in a direction that is represented by the equation y equals 2x plus 3. And I know what you're thinking. You're never going to follow an equation when you're hiking through the forest, but just bear with me. The Boy Scouts are traveling in a direction that is represented by the equation y equals negative x minus 3. And we want to find out where they are going to intersect. So find the coordinates of the point where their paths will cross. So we're going to start by plotting both the Girl Guides and the Boy Scouts. So I'm going to label this one G for Girl Guides. So for my Girl Guides, my slope is 2, or 2 over 1, and my y-intercept is 3. I'm going to go ahead and plot my y-intercept first, and from that y-intercept, I'm going to go up 2 and to the right 1, and I'm going to do some ones on the left-hand side as well. I'm going to go down 2 and to the left 1. I'm going to keep following that pattern until I run out of room on my grid. And I'm going to connect those points using a straight line and label this one G for Girl Guides. And then I'm going to take a look at my second equation. I'm going to call this one B for Boy Scouts. My slope from that line is negative 1. I can make that into a fraction by putting it over 1. and my y-intercept is -3. So I'm going to plot my y-intercept first. From here, I'm going to go down 1 and right 1, down 1, right 1, and so on. I don't have a point of intersection left, so I'm going to go backwards. So up 1 to the left 1, and again follow that path until I find that point of intersection. Connect those points using a straight line and label this B for Boy Scouts so I can identify my point of intersection from my graph. Has the coordinate of -2, -1, so I can say that the Girl Guides and Boy Scouts will cross paths at -2, -1. I could have done my left side, right side check as well. We've done that a while in the previous ones, so this is sufficient for now. Okay? If you have any questions, please reach out to me, send me an email, or sign up for a virtual help session, and I will see you in the next lesson.